Hello, and thank you everyone for being part of the Personalized Nutrients Freedom to Formulate podcast. We have an exciting guest today. We have Dr. Bob Miller, who is a board certified traditional naturopath specializing in the field of genetic specific nutrition. Bob is the founder and president of Functional Genomic Analysis, an online software program that organizes and analyzes genetic SNPs for functional health professionals. Today, we are going to be discussing an extensive executive report on neuroinflammation that has just been launched. This report on neuroinflammation will walk you as the practitioner through the making of the cell membrane and then all the factors that could damage that cell membrane. And it gives an extensive personalized nutraceutical therapy that will address that specific neuroinflammation. So without further ado, I'll turn it over to Dr. Bob Miller to begin discussing this exciting report.
Okay, well, thanks, Justin. And always a pleasure to chat with you. And I think we've been working together for maybe 10, 11 years now. And it's a very good synergy as we help doctors understand where there's weakness and then how they can make personalized products to compensate for it. Before I go into the report, just a couple of quick words. People might wonder, well, why would you want to use genetics to understand what's going on? Because as functional practitioners, there's often the opportunity to look at labs that'll show you if there's inflammation. But when you look at the genetics, you can actually see why. You can look at the underlying root causes. Is there possibly genes that make inflammation overactive? Is there genes that make antioxidants underactive? So there's a big difference between those two. So now you don't have to guess anymore. With precision, you can see where to go. Now, I think most people know this, but we'll just do this very briefly. When we're conceived, we get our genetics, and your DNA is instructions on how to make all the enzymes. You can get what are called SNPs, single nucleotide polymorphisms, where the enzyme may not do its job quite as well. And if one parent gives a SNP, the enzyme might be at 70 to 80% efficiency. If both parents give a SNP, it might be 30 to 40%. And then there's always that possibility there's a couple of SNPs that they actually run faster. So by using genetics, you can actually see where enzymes that make inflammation might be running too fast. Or you might see enzymes that undo inflammation, and they might be running too slow. And then you can, with precision, go in there and find out where there's a need. So the premise that we're looking under here is that just about every illness we have comes from less than optimal cellular membranes. It's called the lipid bilayer. I'm sure most people are familiar with that. Your lipid bilayer surrounds every cell, and even inside the cell, it surrounds parts of the cellular organism. And that is where nutrients go in through the gates. That's where the waste products come out. And that's also inside the cell membrane where we actually have even protection for the cell membrane. So it's a very intricate process. And by using genetics, you can see where there's weakness. And we've just coined this phrase, Justin. It's going to be called cellular CPR. And that is construct, protect, and restore. So that is a phrase we're going to be using over and over. And when you start looking at that concept, which is kind of based on traditional naturopathic philosophy of the environment, you can begin to see that this is not only neuroinflammation, but this would be cardiovascular, this would be autoimmune. And all of those things are related to the strength of your cell membrane. So there's an old adage, you're only as strong as your cell membrane. And if the cell membrane isn't constructed properly, if it's being bombarded with free radicals, if you don't have the ability to protect it, and you don't have the ability to restore it, that's when things start to break down. So now we have, with unprecedented ability, by looking at the functional genetics where there might be weakness. So you following there with me, Justin, on that?
Yes. Cellular CPR, I hear you loud and clear.
Okay,
Construct, protect, and restore.
got it. All right, so here's what happens. You have your patient do a saliva test, saliva collection, then that gets sent to a lab, the DNA gets extracted, and then it's sent to your platform where you can view it in multiple different ways. And I'm going to show you the executive report, but I'll also show you a map that you can look at later. So when you pull up this executive report, it starts out by saying cell membrane construction, genes supporting fat and phospholipid production. So to make a healthy cell membrane, you need the enzyme PEMT to make phosphatidylcholine to build the cell membrane. You also need DHA. So the enzymes FADS1, FADS2, ELOVL2, they all play a role in building that cell membrane. So right out of the gate, if these are not working, if you have genetic mutations in PEMT or any of these, the cell membrane's not being properly manufactured. Now, the cool thing about this report is that we have gone through, we have a team that consists of someone with their master's degree in genetics, where we found the SNPs that are actually actionable, the SNPs that actually change the function. So you can see here on this example, it says PEMT helps the body make phosphatidylcholine, a key fat used to build cell membranes. Then you right here, you'll see that these three, two means both parents gave a mutation, one means one parent did, one means another parent did. And you can see here there's a little down arrow, meaning that this mutation strongly limits the PEMT's ability to make phosphatidylcholine. So what does that mean? It means that phosphatidylcholine is probably a good thing to add, with a few caveats that if there's too much inflammation going on, may not be a good idea. Then if you're a visual kind of person, you can click here, Environmental and Genetic Factors Leading to Inflammation Pathway Map, and you can see here it zoomed in right to that area of the map. And here then you can, for those people who like to be visual, they can see that the PEMT enzyme is weak. And then you can also look at the other factors we don't have time to get into today, but you can see all the factors that lead to the building of the cell membrane. So if you just want the report, you can see that. You never have to go here. But if you're a visual kind of person, you could go there and see what's going on. Now, the thing is, what do you do about it? So compounded nutrients has a product called fatty acid assist. So if you just want to get something off the shelf without making something compounded, you can click on here. It'll actually go into a wellness plan. We won't show that right now. But for those of you who really want to make a customized product, it'll show you the ingredients that you could put in that custom product that would support the cell membrane. So you can click them and that puts them in. Then you have the ability to change the quantities if you so desire. So if you can see here, I just clicked those off. And then you have the ability to say, you know what, they don't have as much constipation as I think they could be happening. So I'm just going to take that down to 100. So in other words, it gives you a number to work with, but you as the practitioner have the ability to play with that. So now you can see this would be like the start of your protocol. All right, then it moves on to the cell membrane protection. So once your cell membranes are made, they need to be protected. So here it shows you that you need CoQ10, you need vitamin E, vitamin K, vitamin A, and vitamin D. And these are the enzymes that if they're not working properly, it may not be appropriate. For example, CoQ10, I think most of the people watching this know that CoQ10 goes from oxidized to reduced. The NQO1 enzyme is what's responsible for that. That's controlled by NRF2, which is inhibited by KEAP1. I understand that's a little bit mind-boggling, but when you really get into it, those are the kind of things you can understand that you may need to support NQO1 for CoQ10 to be effective. So obviously, a lot of the practitioners use CoQ10, and that's a good thing. But if you don't take it from oxidized to reduced, it's not helpful. So you may need to jump in with NQO1 support or NRF2 support to get the CoQ10 going from oxidized to reduced. So in this example, we can see that this individual does have a SNP on the NQO1 enzyme. By the way, if someone would ask me what are the top 10 genes that are necessary for good function, put NQO1 on the list. And then also, if you want to learn about NQO1, just click here. Gives you a little bit of information. If you're curious, well, how common is this? You can get a bell curve to see that this pattern, GA, is 31% of the population in the software. The double A is only 4.3%. So all kinds of data here. Then it'll tell you, here's, again, off-the-shelf product you can use, NADPH assist, or, once again, you can choose the ingredients that you want. Now, you'll notice here that resveratrol is already clicked. Well, that's because we already chose it before. The beauty of this software is that you can choose a supplement that has the same ingredient in, but it will only default to the highest level so it doesn't keep piling up on you. So you're able to, not worry about that you're going to be getting too much of any. All right, then we're going to move on to mycotoxins. Now, mold is getting to be a very serious problem. It's more serious than it's ever been. There's speculation as to why it's getting worse. One is that perhaps EMF is making things worse. But in this map right here, you can see what particularly okra toxin will do. And we don't have time to get into it all today, but it stimulates the enzymes that make what are called gasdermins that will actually start punching holes in the cell membrane. And that's why so many people are sick with mold. So one of the ways that you clear mold is by glucuronidation. And now here it's telling you that one of the genes for glucuronidation is weak. So once again, you can use this product that's available through compounded nutrients, glucuronidation assist. Or again, you can choose the supplements. Now here again, you'll see that the dandelion root was already chosen. So if you want to, again, make it custom, you choose the ingredients that you want to use. Then here it talks about recycling your glutathione. And if you have trouble recycling glutathione, here's what you can do. And again, I'm not going to go through all the details on this, but you can choose the product GSR Assist, or you can pick the ingredients. Now, lead is a huge problem. I was at a conference one time where the speaker said, Here's what I know about everyone who's at this conference. You have at least a little bit of lead inside you. And what lead will do, it will impact what's called the heme cycle. And we need the heme to make your cytochrome P450s, your electron transport chain, your nitric oxide, your sulfuric suox. You need it for catalase and peroxidase. All of those functions need heme. And if you've got lead, that heme cycle will be impacted. So that'll tell you whether you need to jump in there and help with that. Now, this person didn't have any SNPs there, but it'll tell you if it has a SNP where the lead would replace the zinc in the enzyme that does that.
So, Bob, on that, the lead is basically inhibitive of the heme pathway that's responsible for the cytochrome P450 system functionality.
Yes. Plus
So,
more.
so you would say, yeah, plus more, but specifically on that note, would you say that lead is impairing the ability to detoxify? Specifically, you mentioned glucuronidation pathway earlier, right? So if lead is present from a genetic standpoint in your report, then that individual more than likely is going to have a problem with the glucuronidation detoxification.
Well, not only glucuronidation, CYP is your phase one detox. So all of your CYPs, 90% of your CYPs need heme. So your phase one might be impaired. The electron transport might be impaired. Your nitric oxide might be impaired. Sulfide to sulfate could be impaired. Catalase could be impaired. And your peroxidases that take out hydrogen peroxide can be impaired if this heme cycle is disrupted. Now, the genetics doesn't show you if you have lead. You'd have to do other testing for that. But it shows you if you would be vulnerable for lead to replace zinc in this one enzyme. So what we do is when we see that someone's heterozygous or homozygous on that one enzyme, like, let's do a hair analysis or urine analysis and see if there's lead. And then maybe we need to support the heme cycle. Does that make sense?
Yes. Thank
Okay.
you.
All right. Now, again, we go back to, are we making too much inflammation? Interleukin 6 is one of the enzymes that makes inflammation to kill pathogens. But if it's upregulated, it's going to be a problem. So here it's showing you these interleukin 6s could be upregulated. So we made a product called cytochrome 6. And then again, these are the ingredients if you want to choose them. Then there's something called hydrogen sulfide. We could do a whole half hour on hydrogen sulfide because it calms down many of your inflammatory enzymes. And if you've got SNPs in CBS, cysteine betaine synthase, you may not be making enough hydrogen sulfide. So it gives you the ability, maybe we better choose H2S cofactors. Or once again, create it by one ingredient at a time. Okay. Then we talked a little bit about histamine. So when you've got a mutation on a histamine decarboxylase, you might be making too much histamine. So people could be having allergy symptoms. They could be having their mind racing. Downstream from this, it can even create problems with your renin-angiotensin system. The HDC is upregulated here. So once again, product called Histes that can help that, or pick the ingredients. All right, now here's a little bit more on that heme. So here you can see this individual does have the ALAD, this demo that would allow the lead to go in and replace the zinc. And then the uros, that's just another part of the heme cycle. All right. Now, one of the things that we really see over and over again, not just in neuroinflammation, but is hydroxyl radicals. This is one of the most damaging things that can happen inside the body. And quite frankly, what happens is that as part of inflammation, the body will make hydrogen peroxide, and we need three enzymes, catalase, thyrodoxin, and glutathione peroxidase, to reduce that. If we don't, it's called the Fenton reaction, discovered in 1895 by Dr. Fenton, and it will make what are called hydroxyl radicals. And what that does, Justin, it damages the lipids. So here you can see a healthy lipid. Here's a damaged lipid. And then you need glutathione peroxidase 4 to repair it. So glutathione peroxidase 4 will take the oxidized lipid, turn it to the good one. And if we don't, we start punching holes in the cell membrane. And then we have a serious problem. And this isn't just neuroinflammation. This would be cardiovascular. This would be all your degenerative conditions where the lipid is damaged and poking a hole in the cell membrane. So there's many things that can happen here. You can have genetic mutations in any of the three enzymes that take out the hydrogen peroxide. Well, once you know what they are, you can compensate. And then if you don't have enough glutathione or glutathione peroxidase 4, you can get in there and help as well. So you wouldn't know that if you didn't know the genetics. Now, in this example, the only one that's struggling is catalase. The catalase is the only one struggling. Now, if somebody would have had trouble with their thyrodoxin or glutathione peroxidase, it would have shown up. So that's the beauty of the software. It only shows you where there's a problem. So then again, it gives you options how to support the catalase. And here you can see the glutathione peroxidase is weak, and we need to support it there. I know I'm going at a fast clip here, but I'm just trying to get people to get the basic concept of what this can do.
So
Right.
Bob, to summarize it so far, I would say, out of curiosity, what are the specific natural components that you're reaching for on the CPR route, the construction side, the protection, as well as the repair, the
Sure.
restore,
Yeah.
restoration.
Right. Restore. Yeah. So the construction side is your phosphatidylcholine and your DHA. Now the protection is complex because that's a combination of um, excess oxidative stress and or less than antioxidant protection. And then the repair we're looking at right here, and that is that there's enzymes called DYSF, CAV3, and autophagy, because autophagy takes damaged cells and recycles them. Now, this part of the report needs a little bit more work yet, because we still have to put a little bit more in for the repair, but that's going to be coming in the next couple of weeks. So, what might be a good idea is to give everybody the big picture here. I'm going to do a screen share here of what we believe is happening. And that's going to go back to your microglia. The microglia sit in the brain, and they can be in two forms. They can be M2 anti-inflammatory, where they protect, or M1 pro-inflammatory. And you want it here most of the time. And if you have a virus or bacteria, it will trigger and it will make inflammation by turning on these enzymes. And then it'll create peroxynitrite, the hydroxyl radicals, as we spoke about. We need NAD. That's another one of our reports. NAD is needed to hold back the inflammation, because if we don't hold it back here, that's when it goes on to make the gas termins that starts punching holes in the cell membrane. So this is all part of the construct, protect. So protect is a combination of not having too much inflammation and having your antioxidant protection to hold it back. And this is an area that we're really going to be digging into, and this might be another podcast, and that would be microglia. That's a whole other subject as to how to keep that under control. Now, why are we all getting so sick? Why is autism going up? Why is dementia going up? It's the environmental factors. So high fructose corn syrup, COVID, Lyme, fungus and mold, all the environmental factors like air pollution, toxic metals, pesticides, organic pollutants, EMF, all of those are triggering the M1 inflammatory. And then off to the races we go here with all this inflammation. So we believe this is the model that's going to be a pretty good standard for the functional practitioner as to where to exactly find the problem. Because if you just see that there's inflammation and you start throwing glutathione at it, well, that's okay. But if you're not recycling your glutathione, glutathione can backfire on you. A big fad right now is NAD, and NAD is fine. But if the NAD is being pulled down this enzyme right here, NAD can actually backfire on you. So a lot of well-intentioned things that are tried sometimes backfire. That's why it's so important you need this kind of data. So that's what we're working on now, Justin, and I believe this is going to be revolutionizing how we look at cellular health because it's taking you in with precision that we never had before.
Thanks for sharing, Bob. How would a practitioner that is interested, that isn't already part of your subscribing practitioner network at Functional Genomic Analysis, how would they go about signing up to get access to this report for their patients?
So as you can see on the screen there, this is the website that you can go to, and you can request a 30-day free trial. And once you request it, then you're given the account. And if there's a demo account in there, although we have our own genetic test, if you would happen to have like an old and me version 3, version 4, you can load that up, look at it, and then we have a staff, Yvonne and Chrissy can help you with it. Plus, we also do webinars every other Thursday evening where we really delve into this. We're about an hour and a half every other Thursday evening where we train the practitioners how to do that. And also you'll see there's links below that show you how you can subscribe to the webinars. They're free. Myself, Dr. Harold Landis, and other guests lecture every other Thursday evening. And there's also the link to subscribe to the software. So to sum it all up, the world is changing. We're getting more information than we ever had before, and people are getting sicker. And that's why functional medicine is just skyrocketing because people are not getting the answers they wanted. So I would say for the practitioner who says, somebody's inflamed, I tried glutathione and it didn't work. Somebody was anxious, I gave them GABA and it didn't work. Oh, they had MTHFR, but I gave them folate and it didn't work. The hood, so to speak, you can get clues as to why some things may backfire on you. Nobody wants to do anything that makes people worse, but unfortunately that happens when we don't exactly have the data. Same with NAD. If you don't, if your NAD is being turned into what's called a CADP and making inflammation, giving NAD can make things worse. So those are all the things that we need to know so that, that old Hippocratic oath of first do no harm. And it's easy to have good intentions and do harm unless you know where the pitfalls are and how to get yourself out of it.
Well said, Bob. We are grateful for our partnership with you. Our mission at Personalized Nutrients is to make personalized nutritional medicine the standard of healthcare. And that is a very, very broad, very powerful mission. And we could not do it if we were not looking deep at the genetic level. And from a functional genomic analysis and nutritional standpoint, we are grateful to you, Dr. Bob, because of your contributions to all the research and the knowledge in this space, because there's more marketing than data in this natural medicine world. And, the spin stops with you when you really look deep at each individual level and the results speak for themselves. So for anyone listening to this podcast, as a practitioner, we heavily recommend that you become a student of Dr. Bob Miller's to integrate functional genomic analysis and nutrition into your practice today. It will take you to the next level of how you practice integrative and functional medicine. So thank you so much for your time.
Been a pleasure.